All right, let's learn about data structures. Why should we care about data structures, right? What it affect our code qualities, and in our code qualities, some of them are like maintainability, right? And maintainability, underneath there we have a lot of different qualities that we have to care about. Readability, organizations of the code, and modularity of the code. But more importantly, we have to care about the code efficiency that really impact our code quality. And our efficiency depends on the algorithm, and algorithm depends on the data structures, right? So how we pick our data structures wisely is very important. And in algorithm, like if we want to achieve um, our goals from point A to point B, then we need to take such and such steps. And the efficient way to take the steps is really depends on the data structure, right? And we don't care about the hardware speed at all because hardware speeds can be varied, depends on different machines, right? Laptops, big machine, data centers, something like that. And they all have a different speed. But taking the steps, the algorithm steps is very important. So let's look at examples. Um, so in this program, we're trying to calculate and basically print every even number between 2 and 100. And in this case, we increment it by 1 and we start from 2. We filter out by modding the number with 2, right? And then if the mod give 0, then that number is even. So this will take 98 steps. If I'm wrong, let me know. But it's very slow. So we have a second version, but much faster way, right? So it will take only half the size of the steps from the previous problem, the previous methods. So the previous method will take 100% steps, right? And in this case, we just cut off by half the steps that you need to print the even number between 2 and 100. Very fast because we just jumping from number by 2 by adding number 2 steps. So that's why it's really important how our data, the nature of our data. So in this case, because this is what we take advantage of, the numbers increment from 2. 2 plus 1 is 3, 3 plus 1 is 4, 3 plus 1 is 4, and such, right? Until we end up with 100. But if we increment by 2, that means the nature of the data change, and then we get the even number. So that's why we have to be very careful picking about analyzing the data structures of the problem and what we're trying to achieve. And so yeah, and we come up with very smarter way and efficient way to achieve that goal. And the third method is basically, the second example is summations of between 1 to 100. And method 1, we will have to use a for loop. Method 2 is not reliable because there's 50 and 50 will be the number that change, and we will have to add more number behind it as the number, the max number increase, right? So it's not reliable, but very efficient. And method 3, very efficient because this formula already exists, and we can use this, and very efficient. It take only 1 steps and also very reliable. So that is why we have to realize the natures of the data. And if we look at the simple data structures like array, we have read, search, and insertions, and how fast, how they operate. We can analyze them in detailed manner, right? So let's look at our read operation in our array. So if we trying to read a value, right? If we're trying to return a value, we give index positions, and then we return the value from array. So when we get the index positions of particular data from array, we just calculate that positions by adding it, right? So a computer remembered in a memory that index array start from particular address, right? And it add up to that given index positions, right? And then it just jump right there from any random positions in array. That's why we have only one steps for reading it. And this is why the best and the worst case scenarios in arrays are the same. So in this case, if the value doesn't exist, then it will just say, hey, it doesn't exist, and it takes only one steps. And for search, index positions are not given, but the value is. We have to search by value, and we have to return the index positions of that value. So very opposite from reading. And the worst case scenario is we have to search the existing data in array, and if that data doesn't exist, then we have to search all the data, we have to compare all the data inside array, and it will take big O of n times, and that's why searching by value is very slow and worst case scenario. Best case scenario, the value exists at the start of the array because it takes only one step, and we can return index position from there. All right, the insertions. The worst case scenario is basically inserting at the start of the array, because we have to shift all the data before we insert it to the right and insert that number value or that data at the start of the array, and that will take a lot of steps. And the best case scenario is that we insert the data at the end of the array. We don't have to shift anything, we just insert it, right? And also the middle, same with the inserting at the start of the array. We have to shift the right side of the data and then create a gap between them and insert our data in the middle. So that's why it takes a little bit less than inserting from the start, but yeah, still slower. All right, so deleting value from data structures in array. And the worst case will be start from, just like insertions, start from the array, because we create a big gaps from the start and we have to shift all the data to the left. And for the best case scenario, deleting from the back, behind, we don't have to care about it, and we don't have to shift anything else. If we delete in the middle, we delete the data in the middle, and then we have to close the gap by shifting all the data from right to the left. For different structures like set, we have to careful about like duplications. So everything else the same, like reading, searching, but for insertions in our set data structures, we have to first search and compare if data is already exist. The worst case scenario, that data doesn't exist, and or that data exists at the end of our data structures. And the best case scenario, that data exists at the beginning of our data structures, because it's already exists there and we don't have to insert it, and it takes only one step, right? So that's why insertion is slower in sets. And these data structures, how they organize our data and how they operate, we have to pick wisely when it comes to our co-qualities, and our co-qualities are dependent data structures. And there you have it. That's why we have to care about data structures.